Okay, folks, this is what we call our quadrilateral family tree, which makes it very awkward when we get down about here. We'll talk about that in a minute. So this is the granddaddy quadrilateral. Okay, he is a shape, he has four sides, he is closed. That's pretty much it. There is nothing else special about that quadrilateral. But the quadrilateral, like I said, this is great granddaddy quadrilateral, had three kids. There's Kite, and this one has its own properties, its own specialness. The parallelogram has its own properties that the Kite doesn't have. And the trapezoid, it has its own properties that neither the Kite nor the parallelogram have. Okay, all three of these have something that make them special, but all three of them are quadrilaterals. All three of these are closed, meaning there's no hole on them, and they have four sides. Okay, they have all the traits that this guy has, which is basically he's got four sides and he's closed. Oh, and all the angles add up to be 360. That's it. Okay, same thing for this one, same thing for this one, same thing for this one, but it has more special stuff to it. Okay, coming over here to the trapezoid, it had one kid, the isosceles trapezoid. Isosceles trapezoid did not have one. Now, the isosceles trapezoid has all the properties that the trapezoid has, and the quadrilateral, but it also has something else to it that makes it special. We'll talk about that in a minute. Now, the parallelogram had two kids. Okay, both a rectangle and a rhombus are parallelograms. Okay, so they have all the traits that a parallelogram has, plus the traits of the quadrilateral. Okay, and this is where the family tree gets kind of gross, because then these two combine somehow. Yeah, I'm sorry, that's really gross. And they had a kid named Square, and the square has all the properties of the rectangle, the rhombus, the parallelogram, and the quadrilateral. All right, so the square has all the properties of everything above it. All right, so let's turn this over and get these things filled out. Okay, a quadrilateral is a polygon with four sides. All right, I'm going to come over here to a kite. Both pairs of consecutive, meaning one right after the other, sides are congruent, but opposite sides are not congruent. Diagonals are perpendicular. Exactly one pair of opposite angles are congruent. Now, we're going to spend a day on kites, a day on parallelograms, a day on rectangles, a day on rhombi, a day on squares, a day on trapezoids, actually one day on both of these. We're not going to spend a whole day on each one, not each one of these, but you get the point. So you will have plenty of time to see what these things mean. A parallelogram. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Sorry for the pause there, folks, but that's wrong. It's not one pair on this next one. It again is both pair. I don't know why it says one. This should again say both. Both pair of opposite sides are parallel and congruent. Okay, because I mean, it's just this, and then it combines those. I don't know why it went that extra step to combine them, but that's what should be there. Diagonals bisect each other. Both pairs of opposite angles are congruent, and consecutive angles are supplementary. That is the big one that everybody misses. Remember, that means they equal 180 degrees. Consecutive angles are supplementary. All right, on a rectangle, all the properties of a parallelogram has right angles, has not it has 4. I'm going to put 4 in there. 4 right angles, and the diagonals are congruent. That's the first time that's happened so far. All right, a rhombus has all the properties of a parallelogram. All sides are congruent. Diagonals are perpendicular. And, the diagonals bisect the opposite angles. Let's see. A square has all the properties of a parallelogram. All the properties of a rectangle. And all the properties of a rhombus. A square has nothing new special about it. It just has all the traits that its forefathers, or predecessors had. All right, and over here, trapezoid. Trapezoid has exactly 1 pair of opposite sides that are parallel, and exactly 2 pair of consecutive angles that are supplementary. Sorry, that word is missing. There's not a blank there. Supplementary? Ooh, let me try that again. S-U-P. Supplementary. And again, that equals 180. That's what that means. Okay, and then we have an isosceles trapezoid. It has all the properties of a trapezoid. Non-parallel sides are congruent. The diagonals are also congruent. And base angles are congruent. All right, so this is your introduction to quadrilaterals. We will apply this over the next week and a half, and you'll see some examples of it. Probably have a test about 2 weeks from now. All right, so good luck. I hope that made sense.